Uh, Welcome to the November meeting of our online seminar series from the Systematic Review and Meta-analysis SIG. And this series is also co-sponsored by the Meta-analysis Training Institute and the Modern Meta-analysis Research Institute, MADI and MARI. Today we'll be hearing from Diego Campos. Before we get started, let me just explain how this is going to roll. Our speaker will talk for about 35 to 40 minutes, and he's asked that we reserve sort of bigger questions for the end of the talk. If you have questions in the meantime, feel free to punch them into the chat, and we will monitor the chat and interrupt if it's like a very burning immediate question. Also, Mega has put links to our schedule of upcoming talks into the chat, as well as our new Mastodon account if you want to follow us on social media and you're not interested in watching the slow-moving train wreck of Twitter. Let me now introduce our speaker this morning. I'm very pleased to introduce Diego Campos, who is currently a doctoral candidate at the University of Oslo Center for Educational Measurement there. He is truly an international scholar, having completed his BS in psychology at the National University of Columbia and a master's in learning sciences from Ludwig Maximilians Universität München before coming to Oslo. At the Center for Educational Measurement there, he works on methods for meta-analysis of individual participant data, as well as multi-level latent variable modeling. So today he's going to be presenting some of his work on IPD meta-analysis for complex survey data. So welcome, Diego. I'll pass it over to you.
Thank you, James, for the introduction, and thank you to the IRA for the invitation to present my work. I'm very happy and pleased for the opportunity, and I hope this will be very informative for all of you. Yeah, so as James presented or said before, today the title of my presentation is Synthesizing Individual Participant Data Obtained from Complex Sampling Surveys, a two-stage IPD meta-analysis approach. And this is a work I developed with Professor Mike Chong, who is my co-supervisor at the University of Singapore, and Professor Ronnie Schroeder, who is my main supervisor here at the University of Oslo. And he is also in the Zoom, so hi, Ronnie. Okay, so first I would like to open this presentation with some clarification of what do we mean with complex surveys, sampling surveys. So complex sampling surveys are national and international surveys that are organized by governmental organizations or larger institutions. And they generally aim to provide large-scale and representative national and international data on different populations of interest. So some examples of those surveys are the Program for International Student Assessment, PISA study, the Trends in International Mathematics and Sciences study, TEAMS, and the National Assessment of Educational Progress, among others. So for example, the TEAMS study, it's an international study that assesses 4th and 8th grade students, and they aim to assess their mathematics and science learning. And they also collect information on principals, teachers, and school background data with the aim to provide a context about the students' learning. A second example that is very well known is the PISA study. PISA has a different population, so they aim to assess 15-year-old students, mathematics, reading, and science. And they also have some context scenarios that provide information on the context of learning. Up to date, these studies have been running for multiple years. So for example, the PISA study has up to date 6 applications that cover the period between 2000 and 2018. Yeah. So in general, this information from these studies can be used in educational research and in meta-analysis for things such as increasing the understanding of key factors influencing teaching and learning, or identifying key educational issues such as educational inequalities, and of course to inform national strategies for monitoring and improving educational systems, including the evaluation of the effectiveness of curriculum, instructions, and policies. So this is a very interesting data set to work with. And here, complex sampling surveys are special, or we have developed this idea of working with complex sampling surveys and meta-analysis because they are special in a way that they sample and collect data in a different way. So they don't use simple random sampling designs, but they typically include things such as clustering, stratification, disproportionate sampling, and multiple stages of sample selection. So, for example, the multiple sample means that the sampling of individuals happens in 2 stages. So during the first stage, primary sampling units such as regions, schools, or classrooms are selected from the population. And then during the second stage, some individual participants or schools are selected from within each of these primary clusters. And this multi-stage sampling compensates for example, the lack of sampling frame or not having a list of all the members or students in a population, and of course ensures that the samples has sufficient respondents to describe the populations of interest, in this case, educational or the educational context. A second characteristic of complex sampling surveys is the use of probability samples, in which each student and the cluster have different probabilities of being selected. So complex sampling surveys include something that is called survey weights that reflect the inclusion probability of a school or a student of being selected and ensures the representation of the target population. So for example, PISA usually sample the same amount of students across the schools. And however, the number of students across the schools changes. So some schools have more students, while others have less students. And then survey weights are used to ensure that the observations from students coming from bigger schools have a higher weight, so they represent more students or more observations in each of the clusters. And finally, another characteristic of complex sampling surveys is the use of rotated questionnaire designs. So the measures used in complex sampling surveys are also very appealing because they undergone multiple stages of quality assurance that are done before, during, and after the assessment, in which they assess the reliability and validity of the scales. However, as they aim to cover a rather broad set of constructs or aspects, they have something called the rotated questionnaire design, in which they divide the items into different sets of pools or blocks or clusters of items, and then each student will not necessarily take all the blocks or clusters, but rather some subsets. So this design is quite interesting because, of course, it minimizes the assessment time and ensures broad coverage of the constructs of interest. For example, they can have a very comprehensive evaluation of mathematics assessment, evaluating things such as subtraction, addition, multiplication, and division. However, on the other side, of course, there will be more, let's say, measurement error at the level of the student because students will not take all the items. So this data is good to make statements about populations rather than on individual students. Specifically the international large-scale data. The national studies undergone a different sampling, and then there are different types of inferences that researchers can make from those studies. So we believe that the synthesis of data from complex sampling surveys have several benefits for meta-analysis researchers. And the first benefit is related to these large and representative samples from national or international populations. So for example, as I said before, the PISA 2018 study includes information from 79 countries. On the other side, we know that meta-analysis oftentimes exclude studies and reports that are not published in English. However, the information in the PISA study is made available in English, irrespective of the language of the origin of the countries. And therefore, synthesizing information from these studies can enlarge the representation of different geographical areas and social or cultural groups. Additionally, the dependent samples can also be used to directly test the replicability of effects of a study, since all participants are assessed using the same measurement instruments and the same research design. So you have a quite unique opportunity here. And a third benefit from these large samples is that they, of course, can help us to overcome challenges associated with small sample studies in meta-analysis, and increase the precision of the effect size estimates and can improve the generalizability of the effects. Another benefits of the synthesis of this information from complex sample surveys is of course related to high quality measures used in those studies. So complex sampling surveys, as I said before, include standardized measures of achievement, background, and contextual characteristics. And that standardization of instruments can reduce the heterogeneity in the effect sizes that is associated or due to measurement characteristics in meta-analysis studies. So we know primary researchers might have or use different scales across reports. That's something that doesn't happen in these complex sampling surveys, as all students or different countries, for example, take the same instruments. So this, of course, opens the possibility for meta-analysis to establish the comparability of the measures across these groups, for instance, via measurement variant testing or other measurement procedures. And finally, and this is the main point, let's say, of this data, but of course it applies to our data sets, is that we have raw data available. And this, it's a big difference compared to the aggregate data that we usually subtract from primary researchers, because now meta-analysis or researchers in the meta-analysis can control the specification and estimation of statistical models that is used to generate the effect sizes. So for example, a particular relevant application is in the meta-analysis of regression coefficients, right? So oftentimes when we want to synthesize a regression coefficient, we face that authors use different models. They use different control variables or different covariates, and therefore these regression coefficients are not comparable, let's say, across primary studies. This is something that can be overcome with the synthesis of complex sampling survey data, as we have all this information for all different populations, and then we are kind of in control of the type of model that we want to estimate and the synthesis of these regression parameters. A second benefit, of course, of having this raw data is that now we can test we can test also the degree to which a study and participant characteristics are related to variance in study effects. So we can model this within and between study variance, for example, by specifying interactions between some background characteristics and the outcome that is of interest. So that's something, another nice benefit of this type of data. In summary, I just want to synthesize or say that the synthesis of complex survey can help to address some methodological difficulties of meta-analysis and educational research, such as the small samples in primary studies that affect the statistical power to detect effect sizes, the presence of convenient samples in primary research that affect the quality and the magnitude of the effects, and lately, last but not less important, the psychometric or insufficient psychometric quality of outcome measures given by the use of author-designed measure scales rather than standardized measurement instruments. So those are some of the benefits that can bring this type of data to a field of meta-analysis and in educational research. But what do we need to consider if we want to synthesize this information, right? What is important? What is it different to other types of data? So some of the great characteristics are also some of the challenges for the analysis and synthesis of the data. And the first thing is this multi-stage sampling design. So when we analyze and synthesize this data, We need to make sure to address the hierarchical structure of the data sets because this multi-stage cluster sampling design creates a hierarchical structure in which students that are clustered from the same cluster or classroom, let's say in this case, are more similar among each other than students from different clusters, right? And of course, this structure violates some assumptions, such as the assumption of independent residuals, and make the estimation of these parameters under standard errors a bit inefficient. Second, we need to make sure to include survey weights to preserve these links between the sample and the population, and avoid the underestimation of standard errors again, or overestimation of test statistics. So we want to preserve the link between the sample and the real characteristics of the population, because that's one of the advantages of this data. And finally, we need to address this rotated questionnaire design by using either plausible values that are available in these studies. So for example, this rotated questionnaire design means that there is some missing data, right? Some particular studies didn't take all items. So these plausible values are basically some imputed scores that are available in the datasets that take information from the students' responses to the data that they observed and their background characteristics, impute this missing data for each of the participants. So how do we do that in the framework of a synthesis or meta-analysis project? To do that, we propose this two-stage individual participant data meta-analysis. And the approach basically comprises, as I say, two stages. And in the first stage, we will analyze the raw participant data from each study. Of course, and we will use the same analytic model to ensure that the comparability of the resultant effect sizes, right? We still want to have the same analytic model. And in this stage, of course, researchers can use design features of the complex surveys, such as the cluster sampling, the stratification, the plausible values, and the sampling weights. And then, as a result of this stage one, then we will have as many effect sizes as, let's say, subgroups of populations of interest and their sampling variances or respective covariances. Then in stage two, it comes the meta-analysis part. So these meta-analytic models will be used to estimate, of course, the pooled average weighted effect sizes, the indices of heterogeneity, and of course, things such as moderation effects to study between country or between study variance. Something to consider or to be aware of this and the synthesis of complex sampling survey data is that this stage one will usually lead to multiple effect sizes or to dependent effect sizes. So there are different scenarios that you might face when trying to synthesize this data. One of those scenarios is, for example, that you have effect sizes from different multiples surveys, such as TIMSS 2015 and PISA 2015 or NIPES data. And that's something that you need to consider. So like TIMSS, for example, has multiple countries. And if you generate one effect size for each country, then there is some hierarchical dependencies there. Another scenario that you may face when trying to synthesize this data is that you will have effect sizes from a single survey and multiple survey cycles, such as the one that is depicted here in the figure. So we have data from TIMSS 2003, 7, 11, 15, and 19. And then all these effect sizes, of course, there is some study design that might create some dependencies there. And of course, some country characteristics as well. Some advantages of this approach is that, of course, you can make use of different meta-analytic models that have been proposed in the literature to analyze or to account for these dependencies, right? And at this point, some of you might wonder, why then should we use this two-stage IPD meta-analysis approach rather than the one-stage approach, right? Why not to use only a multi-level model, let's say, in which we account for these multiple sources of nesting? So to try to answer that question, I will provide a small example. So let's suppose that we are interested in synthesizing the contextual effect of a level 2 variable, let's say teacher quality. On an outcome variable, let's say student mathematics achievement, 4 participants or individual students that are clustered in schools. And then there's a third level of nesting that it could be the countries and or the studies, right? So to gather information from that, let's say contextual effect using a one-stage model, then we will be mainly interested in this gamma 0 1 parameter. However, in order to be able to use this type of model for the synthesis of complex sampling survey data, we need to account for the different sample designs across all the studies. So for example, PISA and TEAMS might have different stratification criteria, or the survey weights have different meanings. So to put them together into a single model, we need to be able to kind of find a way of making those survey kind of complex survey features comparable across the studies, which as far as I know, it's not possible. However, in the two-stage approach, the different sample designs are not a problem because during this first stage, the cluster sampling, stratification, and sampling weights can be incorporated directly while analyzing the raw data from the students and the generation of the effect sizes. So these effect size and variance estimators will then be meta-analyzed during the second stage. So we can merge data from different complex sampling surveys that not necessarily use the same sampling strategies. The second problem is that the one-stage approach will require having construct scores that are scaled proportionally across the studies. So studies might have different measures, as I said before, to assess mathematics achievement or teaching quality. And then the one-stage approach then will require first us to implement some harmonization procedures that, of course, will depend on the availability of the items, if the different studies share the same items or not. And if they don't, then our approach or our possibilities, analytical possibilities to use this one-stage model will be a bit more difficult, right? However, in the two-stage IPD meta-analysis approach, we have what we all know here. We just need to have a common effect size that is defined in similar weights, and therefore it kind of circumvents this problem of the measurability of the measures. And finally, another point that it will be necessary to address with this one-stage IPD meta-analysis is the overly complex methods that will lead to while analyzing complex sampling survey data. So if we use complex sampling surveys, then we have individual students nested in clusters, nested in countries, and nested in studies. And some of those models are still computationally demanding, and often they are not feasible with the large amount of observations that we have with these data sets. However, the two-stage approach kind of ignores this first level of nesting in the first stage, and then it accommodates because it will be focused on synthesizing our, let's say, contextual effect, and then we will extract this beta parameter and their sampling variances, and then we can use just a meta-analysis model in stage 2 to identify the average weighted effect size of this contextual parameter, and of course, some study-specific deviations. So there are some of the advantages of the two-stage approach or compared to the one-stage approach. Now I would like to focus on providing some specific examples of this. How can we use it? So the first example is we're going to suppose that you are interested in investigating the extent to which girls and boys in secondary schools differ in their digital skills. This is our research question. And to answer this research question, you can use data from ICILS, so the International Computer and Information Literacy Study. And this is, again, a large-scale international assessment similar to TEAMS or to PISA that is conducted every 5 years. So the first cycle was in 2013, and the second cycle was in 2018. ISILs provides information about the digital skills of students nationally and internationally. So it seems to be a great data set for this type of research question. We combined information from ISIS 2013 and ISIS 2018. We will get information from approximately 31 different countries. So that's quite a nice sample. And to synthesize the information, the gender differences in digital skills using ISIS data, then you will need to focus on of first subtracting or extracting from the data sets two sets of variables. The first thing is that you will, of course, need to find information on the constructs of interest, such as gender and computer information literacy in this case. And the second thing is that, of course, you will need to identify the variables that code for this complex data structure, such as the student ID, the country ID, the school ID, the student ID, and the student weights and jackknife codes. So those are variables that are also available in the primary data sets, but that you will need to go through the manuals to try to identify and extract those variables from the data sets. Once you have obtained the data, then then you will be ready to kind of go into this two-stage IPD meta-analysis model. So in the first case, in this case, or in the stage one, then you will need to run, of course, the statistical models that will lead to your effect sizes. So in this case, you can run country-specific multi-group models to estimate the means for the boys and the girls, and their variances. And then you will do this for each participant country that is, let's say, the cluster that you are interested on. Then, of course, you can use those means and those variances to estimate the effect sizes. So in this case, you can estimate the coherence D or a hedge G effect size. And of course, in this analysis of the data, of the primary data, then you will need to be able to use the information on the weights and the plausible values and the stratification. Then once you have obtained the effect sizes, then the second stage, you will meta-analyze those effect sizes. And in this step, it's important to consider the meta-analytic structure of the effect sizes. So for example, in this example, each country or each sample provided one effect size, right? And then we have multiple countries in each of the ISIS study. And additionally, some of the countries participated in ISIS 2013 and ISIS 2018. So we can see that there are some dependencies here in the structure of the data. To analyze this data, of course, you can use the three-level random effects models with effect sizes nested in countries. And then this model will allow you to estimate the average weighted effect size on the mean difference between girls and boys in these computer and information literacy scores. And in this model, you have the effect size variance at level 1. Then you have the within country variance at level 2. And then you have the between country variance at level 3. Right? So once you compute this model, you will obtain, of course, your results. And in this particular example, we obtain G of 0.21. And then, of course, you will also have access to the variance parameters, right? Now, often there will be also primary studies, right, with aggregated data that also provide information on the research questions. So we have the effect sizes that were extracted from the complex sampling surveys. And you can also actually, if you do a systematic review, then you might find also some primary research that provides information on the very same research question. So this is a data that's something that actually Scherer, Siddiq, and Nielsen did. And they found that actually there were 19 studies on the primary literature that provided aggregated data on these gender differences between girls and boys. So how can one combine the aggregated data and the individual participant data, right? What do we need? So of course, the first thing is that we will need comparable effect sizes. So we will need to be able to compute HG, for example, from the aggregate data that's available on the primary studies. And then, of course, you can, again, use these 3-level random effect models to pull an average weighted effect size that combines this aggregate data and the individual participant data. So here in the first level, we will have the sampling variation again. Then in the second level, we will have the within country or within study variation. And then at level 3, you can either use the study as the higher level of nesting or the country as the higher level of nesting, right? However, there are quite a lot of differences between studies or effect sizes that might be computed from reports that are found in the literature and the effect sizes that come from complex sampling surveys. So you might want to explore the differences and similarities in terms of the effect sizes or the variance or heterogeneity at these different levels. So you can tweak, let's say, this 3-level meta-analysis model to explore those differences and similarities. And in the following, I will present the results from these 3 possible modeling approaches. Right. So this is model 1, and this is basically a model that extended the 3-level random effects model into a mixed effects model that include the variable IPD as a moderator variable. And basically, the IPD variable was a dummy code variable where a 1 indicated that the effect size was coming from a complex sampling survey, and the 0 indicated that the effect size was coming from an aggregated data or primary research. This model can also assume that the estimates of the pool effect sizes and the heterogeneity between samples and between studies or countries were specific to the aggregated data and to the individual participant data. So we have a specific heterogeneity indices for each of the types of data sets. When we look at the results of this model, we can see that there is a significant moderation effect of this dummy code variable IPD that suggests that the pool effect sizes differ significantly between the aggregated data and the effect sizes that were coming from the complex sampling survey data. And we observed that the effect sizes are larger for effects that come from these large scale assessments. We also obtain a specific between sample and between country study variances for the aggregated data and the individual participant data. And if we take a look at these various components, then they suggest that the individual participant data exhibit some between country variation, yet not the aggregate data. And we can also observe that the between sample heterogeneity is larger for the aggregated data than for the effect sizes that were coming from individual participant data. A second modeling approach is that we can also use another model that extends again this 3-level mixed effect model, but it constrains the between country or between a study heterogeneity to a single estimate. So we only estimate one parameter there. And then we can do, of course, a model comparison to see which model is fitting better the data. And finally, our model 3, it's again the same model, the 3-level random effects model with IPD as a moderator variable. However, in this model, we only estimate one common heterogeneity index for the IPD and the aggregated data, and then one common between a study or between country heterogeneity estimate for the IPD and the aggregated data again. So once you compare all these 3 models, we can see that for this specific example, the model 2, the 3-level random effects model with a unique specific between sample heterogeneity and a common between a study or between country heterogeneity was the model that better fit our data. Then I want to provide the last example in which this kind of methodology can be used. So another great thing about this two-stage individual participant data meta-analysis for the synthesis of complex sampling survey data is that meta-analysis researchers can also investigate model-based questions that are interested in complex model parameters, such as contextual effects, mediation effects, or interaction parameters. So in this second example, we investigated to what extent is class average student achievement in mathematics related to individual students' mathematics self-concept after controlling for students' individual mathematics performance in primary schools. And to answer this research question, we can synthesize data from the TIMSS study. And as I said before, this TIMSS study assesses the extent to which students in 4th and 8th grade have learned mathematics and science across different countries. So in this particular example, we included data from all TIMSS studies that reported information on our variables of interest. And similarly to our previous example, of course, you will first need to identify and retrieve the data from the constructs of interest and the information about the complex data structure. So in this case, mathematics achievement and self-concept and the complex data structure is pretty much the same because they are the same developers. So in this case, we, of course, again, use our two-stage IPD meta-analysis approach. But in stage 1, we have a multi-level structural equational model. So this is a contextual effect, the nature of our research question. And here we are basically regressing a student's mathematics of concept on a student's mathematical achievement. And we have 2 levels. We have the student level and we have the classroom level. And this is just, as I say, a multi-level structural equational model. So the model also accounts for some measurement error. And our particular, the effect size is defined as the difference between this regression parameter at the classroom level and this regression parameter at the individual or student level. So this is, let's say, the effect size that we will synthesize in our in the stage number 2. And of course, we also retrieve the variance parameters, the variance covariance matrix. So to synthesize this or to calculate an overall estimate of the big fish little pond effect, there are again multiple possibilities. And then the first option is again to use this 3-level random effects model that ignores the study clustering. So here we are only accounting for the country clustering rather than the study clustering. And of course, another similar or analogous model will be to use basically the same model, but instead of having the countries at the level 3, we have the study clustering at level 3. Another possibility is to use this cross-classified random effects model. So in our example, the effect sizes come from multiple samples, right? So we have a country that participated in different TIMSS cycles and therefore has multiple effect sizes. And also, of course, we have multiple effect sizes that are generated for each study. So we can see that this clustering or this nesting and this nesting are independent, and therefore we can estimate a cross-classified random effect models that account for the study nesting and then the country nesting as well. So here are some of the results of these different approaches. And the first thing to note is that the pool average weighted effect size was similar across these 4 different models. There was minus 0.045 that basically indicates the presence of a negative association between classroom mathematics achievement and students' mathematics self-concept. And additionally, we can see that there is a large amount of variation across effect sizes and countries, which is merged into one level when the nesting is ignored. So this is the standard random effect model. Another thing to observe from this example is that the survey nesting did not have a substantial amount of heterogeneity. So one could actually think to ignore this as a hierarchical dependency, as it doesn't have any any variance or heterogeneity at that level. And in fact, when we compare these 4 models, we found that model 2, the 3-level random effects model with effect size nested in countries, was the model that better synthesized our data set. And finally, let's just would like to highlight again that, as I said before, this 2-stage IPD meta-analysis approach allows researchers to model for within sources and the between sources of heterogeneity. So the within sources are modeled at stage 1, and then the between sources are modeled at stage 2. So one can extend, of course, the baseline model, the 3-level random effects model in this case, to account or to investigate how country-level characteristics are associated to this heterogeneity in the effect sizes. So in this example, we have 2 different types of predictors. The first type was some country variant and time variant predictors, that is some cultural dimension scores. And they basically are the same across time points. So it doesn't change for a country that, or for an effect size that was coming from TIMSS 2003 and from an effect size that was coming from TIMSS 2019. And the second source, of course, of predictors is some that are country and time variant predictors. In this case, socioeconomic development. So it will change across different time points. This is the final slide. So I would just like to front up with some take-home messages. So the first thing is that the synthesis of information from complex sampling surveys, I believe, can help researchers to enlarge the generalizability of their meta-analytic conclusions and overcome some of the methodological difficulties with the synthesis of aggregated data from primary studies. The second thing is that, of course, to synthesize, if you wish to synthesize the complex sampling surveys or information from complex sampling surveys, you can use this 2-stage IPD meta-analysis approach, because this approach will enable you to account for these study-specific complex sampling features, and of course, on top, synthesize this information that was coming from complex sampling surveys with information from aggregated data or from different types of studies. Something that we especially really like about this approach of the possibility of having raw data is that you can standardize your analysis across studies. And that means that it will expand the range of model parameters that are available for meta-analysis. So one can think of synthesizing model parameters such as moderation or mediation effects, factor loadings, contextual effects, or cross-level interactions. Something that is quite important is that, of course, this 2-stage IPD meta-analysis will handle these statistical dependencies that will arise at stage 1 and stage 2 by making use, of course, of appropriate models for each of the stages. So in sum, that we believe that given this potential of this approach for the synthesis of complex sampling survey data, it can help researchers, or we encourage researchers to use this type of information for addressing educational research questions in particular. So finally, I would just like to say thanks to and acknowledge my supervisor, Professor Ronnie Scherer, and my co-supervisor, Professor Mike Chung. And I will invite you to also read our upcoming paper. It's a tutorial paper that will be published in Psychological Methods, in which we go through each of these steps that I have tried to summarize here, but with more detail. And we also provide code for the estimation of different type of models. That's it. Thank you very much. And I will be happy to hear, of course, all your questions.
Great. Thank you very much, Diego. I think this is really interesting. And I really appreciated just the clarity of your illustrations and the advantages of this 2-stage approach relative to the 1 stage or other things that people might try. So we've got plenty of time for questions. If you have a question or a thought, feel free to put it in the chat, or you're also welcome to raise your hand and convey your question verbally.
We already have some questions from Ellie. What is the difference between multivariate and multi-level meta-analysis?
Yeah, so basically it's like well, there are different actually modeling approaches, and I have read also some authors who actually parameterize the models in similar ways. But basically in a multivariate meta-analysis, we have this correlated random effect. So it's like when you compute, for example, two effect sizes using the same population, let's say you are interested in synthesizing information of gender differences in mathematics and science. And then you use the same population. Coming back to my examples, you use information from Norway, same students, to use or to generate the gender differences in these two field areas. So you assume that there is some correlation, let's say, between those effect sizes because they are, or both they are estimated using the same sample. And then in the multivariate meta-analysis, we kind of try to account for that correlation between those effects. Something that is very nice of using raw data in general rather than only complex sampling survey data is that covariance or that correlation between those two effect sizes is usually not available, right? So that's why a lot of people have gone for this multi-level approach. But when you have, of course, the raw data, and then you estimate the models, you can actually obtain this variance covariance between those effect sizes or that correlation and plug it into your models. So that's, I think, quite nice of having this raw data.
Another question by Siri. Does conducting IPD meta-analysis also require to search keywords in library databases to get all possible available data or articles?
Yeah, so that's very nice question. Thank you. So yes, generally speaking, of course, if you conduct this in the project in the framework of a systematic review or meta-analysis, you still want to identify all the different types of data that might be available for your research question, right? There is problems, of course, and I think there also have been reported in the literature that there is not as much raw data available as it is, for example, when you are trying to summarize or synthesize effect sizes from just primary research, right? So that's something that I think we will need to be aware. As I have presented here, this is like an approach to synthesize this specific type of data, this complex sampling survey data. But if you are conducting the project in the scope of a systematic review or meta-analysis, of course, you need to be aware of the data limitations. And also, I think you could even still use this two-stage IPD meta-analysis approach to kind of, okay, you compute an overall weighted effect size with the raw data or the individual participant data that's available. And then you can also use the aggregated data to see how those effect sizes might change between the different types of data sources. But yeah, definitely you still, if conducting this in the framework of a systematic review, will need to conduct or do a systematic review. And there are some Prisma actually guidelines for this type of projects for individual participant data meta-analysis. So that is quite nice. So there are some guidelines already available.
Diego, I had a question. I think it's related to Surui's. In the example that you showed where you're comparing the aggregate data results and versus the IPD results from these large-scale assessments, did I have it right? So that the differences, the gender differences were more pronounced in the IPD data?
Yes.
And, right. So the effects were closer to zero. Seemed like they were pretty close to zero on average in the aggregate data, but then they were also like quite a bit more heterogeneous in the aggregate data. Is that right?
Yeah, that's a great point. Yes. So for example, in that specific example, we observed that there were larger effect sizes for the aggregated data than for the primary data. And I haven't done like a proper, let's say, empirical research in this, but one thing that we can see is that in these complex sampling survey studies, there are some, again, standardization of instruments. We have also larger samples that are, let's say, try to be more representative of the whole population. And on
Mhm.
the other side, we have, of course, primary studies that have different degrees of quality, either in the measures that they use to assess the outcomes of interest, but also in the way that they sample. Uh, so that's kind of, let's say, two different study designs or approaches that one kind of also need to make inferences on or like compare on, like, yeah.
Yeah, that it's just something that's really interesting. And it's also like pretty troubling for those of us who spend a lot of time doing aggregate data meta-analysis based on, searches of the primary study literatures.
Yeah, definitely. Yeah.
Yeah.
I think the way forward it is to have this kind of first, like, for what I have seen in the literature, there is not a lot of efforts in synthesize this type of data or information from these like large scale assessments. So I think that that's a first, let's say, great point to kind of see what we have learned from these large studies that provide a lot of information, how they can collaborate to the educational research field. And then on the second step, one can consider to kind of merge these two data sources, because indeed it's a big effort to try to do this as a whole research project. And that's something that you should, of course, need to be aware. Um,
Do you know anything
yeah.
about I mean, you mentioned that like that, the raw data is sort of spottily available from primary studies. Can you say anything about the accessibility of data from these large scale assessments? Like, is it really like easily available so anybody could pull stuff down? Or is it, behind you have to get agreements in place and like, data access agreements and the like?
Yeah. Yeah, this data is actually openly available. So there is different actually organizations like the OECD, the IEA, the International Educational Assessment Office. And in their websites, you can actually just go in and download the data without any kind of agreements or anything like that. There is
Mhm.
also another great source of information that is called the ILSA Gateway, where they actually compile information from all these type of national and international assessments around the world. And then they also provide really nice descriptions of what are the constructs of interest in each of these types of studies, what are the samples. Uh, so this is data that it's there, and it's definitely available for doing this secondary analysis. Yeah. It's quite nice also for PhDs that might want to conduct some studies using this type of data sets. Yeah. And they also have documents actually where they explain the different characteristics and the different properties of the scales. For example, they perform some psychometrical analysis of the scales. They provide information on the samples. So there's quite a lot of information available as well that I find particularly interesting and useful when you want to use this type of data sets.
Yeah, I mean, that
Yeah.
seems like another big advantage of turning to these data sources, like relative to, the information that you might have about the psychometrics of whatever rando scales you find from primary studies.
Yeah. Yeah, I know, for example, Terry has a really great paper on that, what is the effect of having these outer design measures on the estimation of effect sizes, how that can bias the results. So that's quite nice. And of course, it's, as I said, also, it's very nice, like if you want to even go deeper into this research question about the comparability of the measures, then that's something that you can do as well. You can test for how similar or different are these measures across clusters, so like some measurement invariance procedures.
Mhm.
Yeah, that didn't present here, but they're also kind of mentioned in the paper. Yeah.
Yeah, I'll say last call for questions. And seeing none, I'll just offer our thanks again to Diego for sharing this work with us. It's really interesting. And we've got a great schedule of speakers coming up in coming months. Our next seminar will be mid-December with Amy Riegelman talking about transparent and rigorous search strategies for systematic reviews. I'm very excited about that one too. So check out our schedule on the website. Feel free to tweet at, or not tweet, whatever, toot.
Toot.
Toot at us online, not, and hope to see you again. Thank you all for coming.
Thank you, everyone. Bye.